Greetings and welcome once again to my new calculus channel. My name is John Gabriel. And so in the previous three videos, I've been talking a lot about some of the misconceptions that Greek academics have. They're not actually just Greek academics. All academics have those misconceptions. And much of it stems from the fact that they don't have proper definitions. They don't understand proper definitions. They don't understand what it means for a definition to be well-formed or ill-formed. So I'm going to focus on a summary of what I've been telling the Greek viewers in the last three videos. So basically what we have here is a demonstration whereby division is thought of as repeated subtraction. That is totally wrong. It's also totally wrong if it was thought of as repeated addition, which it could have been, by the way. It's not easy to see that if you say 9 divided by 3, that's the same as saying 3 plus 3 plus 3, 3 times. So 9 divided by 3 is 3 times. Now, there's also confusion about how division is written. For example, in the Greek videos, we saw them writing division like this, okay, with a colon. Now, that doesn't mean divide. That means it's a ratio, okay? No division, nothing is happening there. It's just a comparison. No arithmetic measure has taken place. So if we want to say 3 divided by 3, we say it like that, okay? And not like this. That's wrong. Okay, so now let's suppose that it were repeated subtraction. Then 3 divided by 0 is actually 3 minus 0 minus 0 minus 0. So after this subtraction, it'll still be 3. And after this one, it'll still be 3. And after this one, it'll still be 3. And we can easily show by induction that the answer will be 3. But is 3 divided by 0 actually 3? Of course not. Nonsense. Similarly, if we had 3 at the bottom and we tried to measure 0, I'm just showing you that you cannot have 0 on the bottom, but you can't have it on the top too, because look, on the top it would mean 0 minus 3 minus 3 minus 3. So this number here would be minus 3, this one would be minus 6, and we just keep on going up in 3s, minus 9, and who knows what on earth this nonsense is, okay? So it's not possible either to divide by 0 or to divide into 0. Okay, so this is also garbage. Finally, what about this here? Well, watch what happens with the given definition. 0 minus 0 is 0. Minus 0 is 0. As you can see, it's always 0. So given this definition, that division is repeated division, or is repeated subtraction or repeated addition, 0 divided by 0 is 0. Can you see how stupid mainstream academics are? Incredibly stupid. Okay, so, but it doesn't stop there. They go off the path very early when they have definitions like this. They say y over x is equal to p if and only if y is equal to p times x. Well, they haven't even defined multiplication, which, by the way, requires division to be defined first in the correct order. But so they say that, and then if we say 0 over x is equal to p, that means that 0 is equal to p times x, which implies, by the way, that p is equal to 0 if x is not equal to 0. And of course, whatever 0 times 0 is, because multiplication at this stage is defined also incorrectly as the sum of different groups containing the same number of elements. Okay, so that's also wrong. And then, of course, in the final one, we have y divided by 0 is p. This would lead to the uh, conclusion that y is equal to p times 0, which means y must be 0, and that implies that p is equal to 0 over 0. Okay, so p is equal to 0, and of course y is equal to 0 times 0, which is a result that we just blinked our eyes at in this one here, isn't it? Okay, so modern math academics, such as lecturers, especially real analysis lecturers, topology, set theory, are incorrigibly stupid creatures. Don't understand anything about numbers, mathematics. I'm thinking of people like Terence Tao and his ilk. And finally, what does division mean? Okay, if it doesn't mean repeated subtraction or repeated addition, it means this. It means that if we write p divided by q is equal to p over q, like this, okay, that means that this is the result of measuring p using q as a unit. Okay, so if we say 12 divided by 4, okay, then the result is 3 over 1. Okay, why? Because 4 acts as a unit to measure 12, right? And that's what it means. And of course, we could have written this also as just 12 over 4. That's fine, no problem, because 12 over 4 is equal to 3 over 1. See, all that I've done here is I've done some cancellation. But these two here are equivalent fractions. In other words, they have the same measure. If I had to write 12, 4 and 3, 1, you'd be tempted to think they're the same. They're not. Their measures are the same. 12 over 4 and 3 over 1 are the same. But these ratios are not the same. Imagine getting a recipe which tells you use 3 cups of water for every 1 cup of flour. And then you say, oh, that doesn't matter. 12 cups of flour for 4 cups of water. Well, you'd run into problems, as you can see, because they're not the same thing. Okay, they're different things. So definitions are important, people, and good definitions are well-formed definitions. Bad definitions are ill-formed or bad. Okay, good or bad, meaning well-formed or ill-formed. So if you're not already a subscriber to my channel, please become a subscriber, and please click like and follow me on Academia.edu. And by the way, there is a new calculus Discord where you can ask a lot more questions in either of two channels. One is called the lobby and the other one is called questions. I do not own the server, so if you don't behave yourself on the server, you'll be kicked off, and I have nothing to do with it. My name is John Gabriel, and this is a new calculus channel.